So here we have some practice for carboxylic acid nomenclature. Carboxylic acids are probably one of the easier functional groups in terms of some of the common difficulties with nomenclature. And that's because with carboxylic acids, the carbonyl carbon is always going to be carbon number 1. And so sometimes when we're working on nomenclature, the numbering can be a challenge, trying to figure out which end of the chain to start at. But as we can see with carboxylic acids, given that we always start with the carbonyl carbon itself, the numbering actually becomes pretty easy. So in this first one, we have 7 carbons. That means heptane. Now the root name, the parent name for carboxylic acids, is always going to be oic acid. So in this first example, heptane becomes heptanoic acid. And in the second example, octane, because there's 8 carbons in our longest chain, becomes octanoic acid. As I've said for some of these other second semester videos, we're not going to go through a lot of the stereochemistry here. That's something that you've had a lot of practice with by this point. And again, it's in order to focus on the new concepts and keep the length of these videos relatively manageable. So we have a series of substituents here as well. We can go through and add those. 2-bromo. Next would come our ethyl group, which is at carbon 5. We have an isopropyl at 4. And then on carbon 3, we have that pair of methyl groups. So 3,3-dimethyl. Finally, we have a couple of stereocenters. We have a chiral carbon here at 2, as well as 4. But be careful here because it can be really easy to add in a couple extras. Carbon 3, we see 4 substituents, but 2 of them are methyl groups. And carbon 5, again, we see all 4 substituents, but 2 of those substituents are identical. They're ethyl groups. So the only chiral centers in this compound are 2 and 4, and both of those will end up being R. Very similar type of question in question 2. We've got an alcohol, we've got a ketone, a couple methyls again, and an isopropyl group. So we want those in alphabetical order. The alcohol, which goes under the name hydroxy, comes first. This is a good example of a functional group, carboxylic acid, that takes priority over the alcohol. That's why the carboxylic acid is used for our parent name, and the alcohol is identified as a substituent. This will be followed alphabetically by isopropyl. After isopropyl will come our 2 methyls, which we can find at carbons 5 and 7. And then we have the kind of odd one, the ketone. Because the carboxylic acid is part of our parent name, we have to name the ketone as a substituent, and that means the ketone gets named here as 4-oxo, octanoic acid. Finally, what stereocenters are there? Again, there's 3 stereocenters here. We can find them at carbons 2, 3, and 5. Like in the previous example, don't get that mixed up with carbon 7. Carbon 7, not chiral. It's not chiral because two of its substituents to these two methyl groups are identical. So we have 3 stereocenters, 2s, 3r, and 5r. All right, in question 3 here, again, we number our chains starting with the carboxylic acid. Seven carbons means that, again, we're dealing with heptanoic acid. What do we have for substituents? We have the hydroxyl group, the chlorine, and the 2 methyls. So we can easily alphabetize those. 6-chloro. The alcohol is next. So that's 7-hydroxy. And the 2 methyls, 2,2-dimethyl. We have just a single stereocenter at carbon 6. In this case, that stereocenter is going to be S. And because it's the only stereocenter in the compound, we don't need a number in front of it. We can just say S, 6-chloro, 7-hydroxy, 2,2-dimethyl heptanoic acid. When we have multiple chiral centers, in that case, we would need to specify, but here we don't. All right, question 4. There's definitely a lot going on here, but the numbering should again be the most straightforward part of this question. As we have a 9-carbon chain, we know that comes from nonane. But first we have to account for our alkenes. We have 2 of them. They're on consecutive carbons, so a little unusual. We call that, where we have a carbon double bonded to 2 other carbons. It's known as an allene, but we're still, for nomenclature purposes, we treat it the same as any other pair of alkenes. So it's nona 6,7-diene, and then the carboxylic acid gives us the rest of the name. In this question, we're not going to worry about stereochemistry at all. We're just going to get the substituents correct. And as you can see, there's a lot of them. In fact, we have 6 of them. And so it's really just a matter of making a list so that you can get them alphabetical. We have the bromines. We have an isopropyl group. We have a sec-butyl. Now remember, sec-butyl, sec is numerical, so that'll get alphabetized under B. The next carbon over, we have an isobutyl. Iso is not numerical, and so that gets alphabetized under I, just like isopropyl does. And then we have a tert-butyl, which also gets alphabetized under B. So if we were, the numbers I'm going to put here are for the order that we alphabetize them in. Bromine comes first. The one case where we take a numerical prefix into account for alphabetization, sec-butyl and tert-butyl. Sec comes first, tert comes second, isobutyl is next, and finally isopropyl will be our last substituent that we name. The bromine, there's two of them. So that's 6,8-dibromo. Next, we said would be the sec-butyl. So that's 4-sec-butyl. Then 3-tert or T-butyl. 4-isobutyl. And finally, 5-isopropyl. All right, we move on to number 5. Again, hopefully getting predictable at this point. Our carboxylic acid carbon is number 1, and then we just number the chain from there. So 7 carbons makes this hept. At carbon 4, we have an alkene, so hept 4-ene, and then oic acid. We have some substituents here to account for. We have the bromine and chlorine. Those are going to come first alphabetically. As you're getting more and more experience with nomenclature, you may find you're able to do some of this alphabetizing in your head. If not, don't worry about it. Easiest thing you can do is what we did in the previous example. We just made a list and figured out what came first alphabetically. Next is the sulfur, the thiol group. Recall that a thiol, when used as a substituent, gets the name mercapto, and then that ketone is under the name oxo. Finally, we have 2 stereocenters. We have a stereocenter at 2, a stereocenter at 7, and then we also need to worry about the geometry of the alkene at carbon 4. So you can work through those. 2s, 4e, and 7r. All right, our final example is very much like a couple of the recent ones we did. Biggest thing I'd say here is there's a lot going on. So write things out. Make a list as you're working through it. I'm going to erase our previous answer just to give us some extra space to work with. But again, what we should find to be the most straightforward part of this is that carboxylic acid carbon is carbon 1. And so we have here a 9-carbon chain. So that's going to be from nonane. There's 2 alkenes. One's at 2, one's at 6. So 2,6-diene. And then the carboxylic acid, oic acid. Now, what about all the substituents? Let's go ahead and make a list because there's going to be a lot to keep track of. Carbon 2, we have a chlorine. Carbon 3, bromine. Carbon 4, we have a methyl. Carbon 5, we have a ketone, so that means we're dealing with 5-oxo. 6, we have an alcohol, so 6-hydroxy. Carbon 7, we have a thiol, which gives us 7-mercapto. And then at carbon 8, we have another alcohol. So when we're writing this out, we'll make sure we get the dihydroxy in there. One thing to be careful of, it can be really easy to want to say 8-methyl here, but that methyl there is part of our parent chain, so don't label that methyl as a substituent. So how are these going to be alphabetized? Bromine will come first, then chlorine, hydroxy, followed by mercapto, methyl, and oxo. So now we just need to put these in order. 3-bromo, 2-chloro, 6-8. There's 2 of them. We've got to add in our dihydroxy. Next is 7-mercapto. 4-methyl. And 5-oxo. Final step would be to consider any stereochemistry. We have 2 alkenes that need to have E and Z assigned. And then we have 2 chiral centers to assign R and S. And you can go through and do that. 2E, 4S, 6E, and 8R.